Dear students, welcome to mathematics online classes. In this class, we will solve problems of the exercise 10.3. See, first problem, second problem, those are easy ones. See, what is the first question in the exercise, NCERT exercise? Find the angle between two vectors A and B with magnitudes root 3 and 2 respectively, having A dot B is equal to square root of 6. A dot B is given, magnitude of A is equal to root 3, it is given, magnitude of B is equal to 2 is given. We need to find out a theta. So, one problem I have solved similar to this in the examples. You should solve this problem using the formula cos theta is equal to A dot B by magnitude of A into magnitude of B. So, I am leaving that question to you only in the exercise 10.3. Similarly, question number 2 also. Find the angle between the vectors I minus 2j plus 3k and 3i minus 2j plus k. You take first vector as vector A and second vector as a vector B. One problem similar to this already I have solved. Then you same formula cos theta is equal to A dot B by magnitude of A into magnitude of B. A dot B, dot product of two vectors in component form. Use that, find out A dot B, magnitude of A you find, magnitude of B you find, then find the value of theta, cross check your answers with the textbook answers. Those are correct only. Question number 3 I will solve. Find the projection of the vector I minus j on the vector I plus j. So, here what you do, take the first vector as vector A. Vector A is equal to I minus j and vector B is equal to I plus j. What I have to find out? I have to find out a projection of the vector I minus j on the vector I plus j. So, here I have to find out a projection of vector A on vector B. I have to find out. This is our question. Projection of A on B is nothing but A dot B divided by magnitude of vector B. Let us find out A dot B first. A dot B is equal to I minus j, which is in dot product with I plus j. So, dot product I into I, that is, otherwise it is like A square minus B square formula, A minus B into A plus B, A square minus B square, no. So, I can write here magnitude of I square minus magnitude of j square. What is magnitude of I? 1. What is magnitude of j? 1, because those are unit vectors. So, what is A dot B here? A dot B is 0. No need to find out magnitude of B then, numerator is becoming 0. So, no need to find out magnitude of vector B. Now, projection of vector A on vector B is 0 by magnitude of vector B. 0 by anything is 0. There is no projection at all. This is about question number 3. Now, question number 4. Question number 4, find the projection of the one vector and another one vector. One vector, first vector we take it as vector A, second vector we take it as vector B. So, projection of first vector and second vector, you find out, you write it like projection of vector A on B, this is equal to A dot B by magnitude of vector B. I hope you will solve this question number 4. I am leaving this question to you only. Now, move on to question number 5. Show that each of the given 3 vectors is a unit vector. Show that each of the given vector is a unit vector. There are 3 vectors given to us. First one is 1 by 7 into 2i plus 3j plus 6k, comma 1 by 7 into 3i minus 6j plus 2k comma 1 by 7 into comma 1 by 7 into 6i plus 2j minus 3k. Three vectors are given to us. Also show that they are mutually perpendicular to each other. Also show that they are mutually perpendicular to each other. This is our question. Yes, first part of the question we will take first. Each of the vector is a unit vector we have to show. Unit vector means its magnitude is 1. Let us find out the magnitude of the vector. If it is 1, then it is a unit vector, that is all. Let me take this first as vector A. Vector A is equal to 1 by 7 into, see this 1 by 7 will get multiplied with all three components. This become 2 by 7 into I cap, 3 by 7 into j cap plus 6 by 7 into k cap. This is vector A. And now let me take this as vector B. Vector B, same thing happens here also, 1 by 7 will get multiplied. So this is 3 by 7 into I cap, 3 by 7 into I cap minus 6 by 7 into j cap plus 2 by 7 into k cap. Next, vector C is equal to 6 by 7 into I cap plus 2 by 7 into j cap minus 3 by 7 into k cap. This is vector C. Now we have to show all three vectors are unit vectors. Let us find out magnitude of vector A. Magnitude of vector A is equal to, this is square root of 2 by 7 square plus 3 by 7 square plus 6 by 7 square. So square root of 7 square, 7 square, 7 square, 49 is the LCM. Here 2 square 4, 3 square 9, here 6 square 36. This is square root of 4 plus 36, 40, 40 plus 9, 49, 49, 49 get cancelled, square root of 1 means 1. Magnitude of vector A is equal to 1 means I am showing that vector A is a unit vector. Next, find out magnitude of vector B. Magnitude of vector B is 3 by 7 square root of 3 by 7 square plus minus 6 by 7 square plus 2 by 7 square. This is square root of 49 will be the LCM again. 7 square, 7 square, 7 square is there. This is 3, 3 square means 9, minus 6 square is plus 36 plus 4. Again it is, you see, 36 plus 4, 40, 40 plus 9, 49, 49 by 49 get cancels out, square root of 1 means 1. What is this? This is magnitude of vector B. Next, magnitude of vector C is equal to square root of 6 by 7 square plus 2 by 7 square plus minus 3 by 7 square. This is square root of, again 49 will be the LCM. Here is 36 plus 4 plus 9. We have square root of 49 by 49. This get cancels out, square root of 1 means 1. What is this? Magnitude of vector C is also equal to 1. Therefore the given vectors are unit vectors. Therefore the given vectors are unit vectors. This is first part of the problem, that is completed now. Now we will take a second part of the problem. Okay, let us now to erase this A, B and C. This is 3 by 7 plus 2 by 7 into I cap. What is this? This is vector A is equal to, okay, second part of the problem is show that they are mutually perpendicular to each other. When two vectors are perpendicular to each other according to the dot product of two vectors, when their dot product is 0. If A dot B is equal to 0, then A and B are perpendicular to each other. Here I have to show that all three vectors are perpendicular to each other. Means I have to show that A dot B is equal to 0, B dot C is equal to 0 and C dot A is equal to 0. Let us find out all those. First of all, finding A dot B. A dot B is 2 by 7 into I cap plus 3 by 7 into j cap plus 6 by 7 into k cap, which is in dot product with 3 by 7 into I cap minus 6 by 7 into j cap plus 2 by 7 into k cap. Yes, corresponding components multiplication. 2 by 7 into 3 by 7, 49 denominator and numerator will be 6 by 49. Next, plus 3 by 7 minus 6 by 7, plus into minus, minus 6 3 is 18, 18 by 49. Next, plus into plus, plus 6 into 2, 12, 12 by 49. How much is this? 49 will be the LCM. 6 minus 18 plus 12. This is nothing but 0. 6 plus 12, 18. 18 minus 18 is 0. What is this? A dot B. Dot product of A and B is 0. Okay. Next, let us find out B dot C. Dot product of vector B and C. B is 3 by 7 into I cap minus 6 by 7 into j cap plus 2 by 7 into k cap, which is in dot product with 6 by 7 into I cap plus 2 by 7 into j cap minus 3 by 7 into k cap. Now, dot product of these two vectors. 3 by 7 into 6 by 7. By 7 is there, that is 49. 6 into 3 is 18. Next, minus into plus, minus 7 into 7, 49. 6 into 2 is 12. Next, 7 into 7, that is 49. 2 into 3 is 6. 18 by 49 minus 12 by 49 minus 6 by 49. 49 is the LCM. This become 18 minus 12 minus 6. Numerator is 0. So that is 0. B dot C is also 0. Next, let us find out A dot C. A dot C or C dot A, both are fine. A dot C is 2 by 7 into I cap plus 3 by 7 into j cap plus 6 by 7 into k cap, which is in dot product with 6 by 7 into I cap plus 2 by 7 into j cap minus 3 by 7 into k cap. Okay. Now taking the dot product of these two vectors, first one 2 by 7 into 6 by 7, numerator will be 12, 12 by 49, plus 3 by 7 into 2 by 7 is plus 6 by 49. Plus into minus, minus 6 3 is 18, 18 by 49. This is 49, 12 plus 6 minus 18. Numerator is 0, so that is 0. You say from these three I can write A dot B is equal to 0, B dot C is equal to 0, A dot C is equal to 0. I can write here A dot B is equal to B dot C is equal to C dot A is equal to 0. Therefore, all three vectors are mutually perpendicular to each other. All three vectors are mutually perpendicular. This is about question number 5 in the exercise 10.3. Now, we will take next question, that is question number 6. Find magnitude of vector A and magnitude of vector B. Find magnitude of vector A and magnitude of vector B if vector A plus vector B in dot product with vector A minus vector B is equal to 8 and magnitude of vector A is equal to 8 times magnitude of vector B. Magnitude of vector A is equal to 8 times magnitude of vector B. We need to find out magnitude of vector A and magnitude of vector B. Here two equations they have given you, two unknowns we need to find out. Easily we can do it. They have given you A plus B which is in dot product with A minus B equal to 8. Is it like A plus B into A minus B? Okay. It can be written as A square minus B square, means magnitude of A square minus magnitude of vector B square equal to 8. Let us take this as equation 1. And they have given you another one, that is magnitude of vector A is equal to 8 times magnitude of vector B. Let us take this as equation 2. By solving 1 and 2, we need to find out magnitude of vector A and magnitude of vector B. Very simple it is. From equation 2, let us substitute modulus of magnitude of vector A in equation 1. Okay. Substituting 2 in 1. Magnitude of vector A is equal to 8 times vector B. This is 8 times magnitude of vector B. Here this square I will write as it is minus magnitude of vector B square, which is equal to 8. This is 8 square 64. 64 into magnitude of vector B square minus magnitude of vector B square equal to 8. 64 times it is minus 1 times. This becomes 63 times. 63 into magnitude of vector B square equal to 8. Then we have magnitude of vector B square is equal to 8 by 63. Now what is this magnitude of vector B is equal to? Taking square root on both sides, this is square root of 8 by square root of 63. Square root of 8 can be written as 4 into 2. 4 square root of 4 is 2. This becomes 2 into root 2. 63 can be written as 9 into square root of 7. 9 square root of 9 is 3. 3 into square root of 7. Okay. So what is magnitude of vector B is equal to? Magnitude of vector B is equal to 2 by 3 into square root of 2 by 7. You can leave it here, or if you can rationalize the denominator also, no problem. Magnitude of vector B we found. Then finding the magnitude of vector A, very simple. Substitute in any one of the expressions. Substituting in equation 2, equation 2 implies magnitude of vector A is equal to 8 times magnitude of vector B, means that is 2 by 3 into square root of 2 by 7. 8 2s are 16. 16 by 3 into square root of 2 by 7. What is this? This is magnitude of vector A is equal to. So this is the answer for question number 6. Next, question number 7. Evaluate the product. Question number 7. Evaluate the product. 3a minus 5b, 3a minus 5b, which is in dot product with 2a plus 7b, 2a plus 7b. Okay, I need to find out this product. Simple it is. 3a minus 5b, which is in dot product with 2a plus 7b. We know that dot product is distributive. As dot product is distributive, we will take this second one dot product with the 3a first, then followed by 5b. So I can write here 3a which is in dot product with 2a plus 7b, and here minus is there, minus 5 into vector b, which is in dot product with 2a plus 7b. Okay, here 3a into 2a, 3 into 3 2s are 6, 6 into A dot A. A dot A means magnitude of A square. Next 3A into 7B. 3 into 7 is 21 A dot B. Minus of 5B. 5 into 2 is 10. 10 into B dot A it is. Next minus 5B plus 7B. Plus into minus. Minus 5 sevens are 35. B dot B is magnitude of B square. So we have here 6 times magnitude of vector A square minus 35 times magnitude of B square. Here 21 times A dot B, here minus 10 times A dot B. It is B dot A as it is commutative. A B dot A is same as A dot B. Okay. 21 minus 10 times means it is plus 11 times. 11 times A dot B. This is the answer for evaluating the product. Now we will take the next question, that is question number 8. Question number 8 is find the magnitude of two vectors. Find the magnitude of two vectors find the magnitude of two vectors A and B, vector A and vector B having the same magnitude, and such that the angle between them is 60 degree. Angle between them is 60 degree, and their scalar product is 1 by 2, and their scalar product is 1 by 2. Question number 8 we are solving. Find the magnitude of two vectors A and B. Means what I have to find out here? We need to find magnitude of A and magnitude of B. Magnitude of A is equal to question mark and magnitude of B is equal to question mark. Having the same magnitude, that means what? It is given magnitude of A is equal to magnitude of B, such that angle between them is 60 degree. Angle between them, theta is equal to 60 degree, and their scalar product and dot product both are same one. Scalar product is 1 by 2. That means A dot B is 1 by 2. Okay. A dot B is there, angle is there, magnitude of A and B they are asking which formula to use. The formula which involves all three quantities is A dot B is equal to magnitude of A into magnitude of B into cos theta. Theta we will substitute. A dot B is directly given to us, so we will find out this very easy. Okay, now substituting, otherwise we will write one more step. Okay, let us substitute. A dot B is 1 by 2, which is equal to magnitude of A into, what is this magnitude of B? They have given you having the same magnitude, means magnitude of A is equal to magnitude of B. This magnitude of B is there, no? This one also we will write it as magnitude of A only, into cos theta, means cos 60 degree. 1 by 2 into magnitude of A into magnitude of A is magnitude of A square. Cos 60 degree is 1 by 2. 1 by 2, 1 by 2 get cancels out. What I have? I have 1 is equal to magnitude of A square. Magnitude of A square is 1. What about magnitude of A? So this implies magnitude of A is equal to 1. If magnitude of A is equal to 1, what is magnitude of B? As both are same, magnitude of B is also equal to 1 only. This implies magnitude of A is equal to 1 and magnitude of B is equal to 1. This is question number 8. Okay. Now, next question number 9. Question number 9 is similar to a problem I solved already. Question number 9. Find magnitude of vector x if for a unit vector. That means they have given you magnitude of vector A is equal to 1. That is given to us. We need to find out magnitude of vector x. There is an expression given to us. I have solved similar problem in the examples. Now that question number 9 is left to you. I will move on to the next question, that is question number 10. Question number 10 is if vector A is equal to 2i plus 2j plus 3k, comma vector B is equal to minus I plus 2j plus k, and C is equal to, and vector C is equal to 3i plus j, 3i plus j, are such that vector A plus lambda times vector B is perpendicular to vector C. Then find the value of lambda. Okay, let us understand what is given first of all. A is equal to B is equal to C is equal to, there are 3 vectors. They have given you A plus lambda B is perpendicular to vector C. Find the value of lambda. Lambda is equal to question mark. This sentence we read again. A plus lambda B is perpendicular to vector C. That means what? If A is perpendicular to B means A dot B is equal to 0. A plus lambda B is perpendicular to C means A plus lambda B, which is in dot product with vector C, is 0. Using that equation, we need to find out the value of lambda here. Very simple one. First of all, let us find out A plus lambda B vector. A plus lambda B is, vector A is what? 2i plus 2j plus 3k plus lambda times vector B is minus I plus 2j plus k. Now here I will write one more step, 2i plus 2j plus 3k. This lambda will get multiplied to all the terms, minus lambda I plus 2 lambda j plus lambda k. Now adding the I components, 2i and minus lambda, it will be 2 minus lambda into I cap, plus here 2j, here plus 2 lambda, means it is 2 plus 2 lambda into j cap. Here 3k plus lambda k, means it is 3 plus lambda into k cap. What is this? This is vector A plus lambda times vector B. Okay. Vector C is directly given to us. Vector C is 3i plus j. And what they have given you? They have given you that A plus lambda B is perpendicular to vector C. That means they have given you A plus lambda B, which is in dot product with vector C, is equal to null, means 0, they are saying. Now substitute this. A plus lambda B is 2 minus lambda into I cap plus 2 plus 2 lambda into j cap plus 3 plus lambda into k cap. This is a plus lambda b. Whole vector is in dot product with the vector c, that is 3i plus j. 3i plus j. This is dot product. This is equal to 0. With this expression we need to find out the value of lambda. Here dot product is there, taking the corresponding components product. I component is 2 minus lambda, here I component is 3. This is 3 into 2 minus lambda. Next j component, here 2 plus 2 lambda, 2 plus 2 lambda, here their j component is 1. Next k component is 3 plus lambda, here j component k component is not there, into 0, which is equal to 0. This part is 0. 3 will get multiplied with these two. 3 into 2 6 minus 3 lambda plus 2 plus 2 lambda plus 0 equal to 0, means that is 0 only. Now we have 6 plus 2 8 minus 3 lambda plus 2 lambda is minus lambda, which is equal to 0. Therefore, what is the value of lambda? Value of lambda is 8. Yes. Next, question number 10 completed. Now we will take the next question, that is question number 11. Let me erase it first. Question number 11 is, show that magnitude of vector A into vector B plus magnitude of vector B into vector A is perpendicular to magnitude of vector A into vector B minus magnitude of vector B into vector A for any two non-zero vectors, for any two non-zero vectors A and B, for any two non-zero vectors A and B. Okay. If all of us know that if two vectors are perpendicular to each other, then their dot product will be 0. Here they have given you two vectors. This is first vector, this is second vector. We need to show that these two vectors are perpendicular to each other. Means let us take product of these two, means dot product of these two vectors. If we get 0, then these two are perpendicular to each other. That's all. Let us take a dot product of these two. First vector is magnitude of vector A into vector B plus magnitude of vector B into vector A, which is in dot product with the second vector. Magnitude of vector A into vector B minus of magnitude of vector B into vector A. This is equal to, again here, as dot product is distributive, we will take the dot product of second vector with the first component, that is magnitude of vector A into vector B in dot product with the magnitude of vector A into vector B minus magnitude of vector B into vector A. Now plus of taking the dot product with second one, magnitude of vector B into vector A, which is in dot product with the magnitude of vector A into vector B minus magnitude of vector B into vector A. Okay. Now dot product of these two. See, magnitude of vector A is a scalar quantity. It is like 2, 3, 4, whatever. Here also magnitude of vector A is there. That is scalar quantity. Only two vectors are there, vector B and vector B. This can be written as magnitude of vector A square into B dot B. Next, dot product with second one, minus of, here magnitude of vector A is a scalar quantity, magnitude of vector B is a scalar quantity. Let us write these two together first. Magnitude of vector A into magnitude of vector B, these are outside. Here vector B is there, here vector A is there. So dot product is between vector A and B. Next, plus of dot product with second component here. B is a scalar quantity, magnitude of vector B, here magnitude of vector A. Let us write these two together outs. Magnitude of vector A into magnitude of vector B. Here vector A in dot product with vector B. Vector A dot product with vector B. Now plus into minus, minus. Here magnitude of vector B into magnitude of vector B. Magnitude of vector B square I will write. And then dot product between A and A. A dot A. Now this is magnitude of A square. What is B dot B? B dot B is magnitude of B square. This is magnitude of B square minus of magnitude of A into magnitude of B into A dot B can be written as, sorry, B dot A can be written as A dot B because dot product is commutative, plus magnitude of vector A into magnitude of vector B into A dot B minus of magnitude of B square. A dot A means magnitude of A square. Okay. A square into B square, A square into B square get cancels out. Here same thing is there, here same thing is there. One is with minus, another one is with plus. Get cancels. See, dot product of these two vectors is 0, you know, means these two vectors are perpendicular to each other. Therefore, magnitude of vector A into vector B plus magnitude of vector B into vector A is perpendicular to magnitude of vector A into vector B minus magnitude of vector B into vector A. This is about question number 11. Okay, we will stop it here. Remaining we will continue in the next class. Thank you.